Hello everybody, I'm Apasu and welcome to my course on IoT, cybersecurity and risk management. In the last session, we have looked into what can be the risk mitigation for the IoT devices. So in this chapter, we'll be discussing about the challenges of implementing those risk mitigation. So let's start by one. The first is protect device security, and inside that we have discussed about the asset management. But when we are talking about the asset management, first issue can be the device has a built-in unique identifier, but it may possible for the IoT devices unique identifier is not available. So and then in that case it may complicate device management, including remote access and vulnerability management. Second challenge can be the device can interface with enterprise asset management system, but the IoT device may not be able to participate in centralized asset management system. What it means, let's suppose you have implemented Focus Scout so that the devices can be scanned and your inventory can be updated, but it may possible IoT device is not compatible for that. So in that particular case, you may have to use the multiple asset management systems, or you may have to perform the asset inventory task manually. The third challenge is IoT device may not be directly connected to any of the organization network. Then what can be the issue? You may have to use the separate asset management system or service or manual asset management process. Then the third challenge what we are talking about is device can provide the organization sufficient visibility into its characteristic, but in case of IoT devices may be a black box that provide little to no information on its hardware, software, and firmware, and this may complicate all aspects of device management and risk management. Fourth challenge can be the device or devices manufacturer can inform the organization of all external software and services the device uses, such as software running on or dynamic downloaded from the cloud. But in IoT devices, not all the IoT devices external dependencies may be revealed. So if you don't know it is then you cannot manage the risk of external software and services. This can be corresponding to the risk management. Now if we come to the vulnerability, the challenges can be the manufacturer will provide patches and upgrades for all software and firmware throughout uh, each device lifespan. But in case of IoT devices, manufacturer may not release the patch or upgrade of an IoT devices. So then we cannot remove known vulnerabilities. And second is manufacturer may have stopped releasing patches and upgrades for the devices while it is still device is in use. So may not be able to remove known vulnerabilities in the future. The next challenge is device either has its own secure built-in patch, upgrade, and configuration management capability, or can interface with enterprise vulnerability management system with such capabilities. But in case of IoT devices, they may not be capable of having its software patches upgraded automatically. Then we cannot remove known vulnerability, or it may be too risky to install patches or upgrades or make configuration changes without extensive testing and preparation. First, and implemented changes may require operational outage and inevitably cause outage. So maybe significant delay in removing known vulnerability, or IoT devices may be able to participate in centralized vulnerability management system, but that may have to use the numerous vulnerability management system instead of one, may have to perform vulnerability management tasks manually or periodically. Example, manually installing patches, manually checking of softwares. Next is IoT devices may not offer the ability to change the software configuration or may not offer the feature organization want. So then again cannot remove known vulnerability, cannot achieve the the principle of least functionality by disabling the unneeded services and functions and cannot restrict sensor activation and uses. And next is device can either support the use of vulnerability scanner or provide full in vulnerability identification and reporting capability. So there may not be a vulnerability scanner that can run on or against the IoT device. So in that case, you cannot automatically identify the vulnerability, or IoT device may not offer any built-in capability to identify and report on vulnerability. So in that case as well, you cannot automatically identify the known vulnerabilities. Next come we can talk about the access management. Here we can say the device can uniquely identify each user, device, process attempting to logically access it, but it may possible IoT device may not support any use of identifiers, so cannot identify and authenticate users, devices, and processes, or device may only support the use of one or more shared identifiers. So cannot uniquely identify users, device, or processes, complicates credential management because of shared credential. The IoT device may require the use of identifier, but only in certain cases. The same way, then we cannot identify and authenticate some users, devices, and processes. The next expectation what we are having is the device can conceal password character from display when a user enter the password on a device while using maybe the keyboard or a touch screen, but the IoT device may not support the concealment of the displaying character. What it has likelihood of credential theft. Next is the device can authenticate each user device attempting the logical access to it. It may possible IoT device may not support the use of non-tribal credential. So cannot identify and authenticate users, devices, and processes, such as increasing the chances of unauthorized access and tampering. IoT device may not support the use of strong credentials such as cryptographic tokens, multi-factor authentication, or further situation that merits them. So increasing the chance of unauthorized access and tampering through credential misuse. Next expectation is the device can use existing enterprise authenticator and authorization mechanism, but IoT device may not support the use of existing enterprise user authentication system. So need one or more additional accounts in credential for each user. Next is the device can restrict each user, device, or process to minimize the logical access, logical privileges necessary, but device may not support use of logical access privileges within the device that is sufficient for a given situation. It means allows authorized users, devices, or processes to intentionally or inventively use privileges that they should not, and allow an attacker who gains unauthorized access to an account to have even greater access that the account should have. The IoT devices may not support use of logical access privilege to restrict network communication in and out of the devices that is sufficient for given situation. What it can do, it allows the authorized user and devices and process to intentional or inevitably conduct network communication they should not be able to. And next can be the IoT device use of these security features may not sufficiently modify, so cannot gain the immediate access to the IoT devices when needed to use to manage. Next is the device has adequate built-in security controls to protect it from tampering. So the IoT devices may be deployed in an area where the people who are not authorized to access the device may do so. When authorized people can access the device in unauthorized way. Then what will happen? So it will allow an attacker to have the direct physical access to the device and tamper with them, including adding or removing the storage media, connecting peripheral devices. The next is in the incident detection. So what can be done? Device can log its operational and security event. That's our assumption, but it may possible in case of IoT devices may not be able to log its operational and security events at all or in sufficient detail. So this increase the likelihood of malicious activity going undetected, cannot confirm and reconstruct incident from log entries. The IoT device may continue operating even when a logging fail occur. This increase the likelihood of malicious activity going undetected. Next assumption is like, moreover, like the device can interface with existing enterprise log management system, but in case of IoT devices, they may not be able to participate in the enterprise log management system. So because of that, may have to use the numerous log management system instance of one, may have to perform the log management task manually, or increase the likelihood of malicious activity going undetected. Next is the devices can facilitate the detection of potential incident by internal and or external control, such as intrusion prevention system, anti-malware utilities, and file integrity checking mechanism. The IoT device may not able to execute internal detection control or interact with external detection control without adversely affect device operation. Increase the likelihood of malicious code, infections, and other unauthorized activities occur and going undetected. An IoT device may not provide the control with the visibility needed to detect the incident efficiently and effectively. This can increase the likelihood of malicious code and other unauthorized activities going undetected. Next is the device can support even an uh, incident analysis activity, but in case of IoT devices, it may not provide the analysis with sufficient access to the device's resources in order to do the necessary analysis. So what can happen? It cannot do who cannot use forensic tools for information gathering and analysis. So this is what the challenges we are having while implementing the risk remediation for protect device security. Thank you for joining.